Hi, my name is Eugene Lee, and in this presentation I'm going to give a brief summary of Professor Adam Reiss's presentation here at Georgia Tech. He gave this on October 14th, 2025 at the Cloud Undergraduate Learning Commons. So Professor Reiss is a physics professor at Johns Hopkins University, and he won the 2011 Nobel Prize in Physics for his discovery that the expansion of the universe is accelerating. To give a little bit of historical context, basically in the earliest 20th century, Einstein believed that the universe was static, meaning it was neither expanding nor contracting. But when he came up with his theory of general relativity, he found out that these two theories kind of contradicted each other. So Einstein added a cosmological constant to his general relativity equations to account for this. Later on, Edwin Hubble, who is another famous physicist, showed that the universe is in fact expanding since galaxies are moving further away from us, and he measured this through the redshift phenomenon, which is basically the phenomenon where light becomes redder as the emitter moves further away from us. And then another important fact to know relates to type 1a supernovas, which are a type of supernovas that occur when distant stars explode and producing lots of light. The special thing about type 1a supernovas are that they form from the explosions of white dwarf stars, and they have approximately the same brightness. And so comparing the measured brightness of these supernovas to the expected brightness can tell us how far away the supernovas are, and then that therefore tells us how far away the galaxies that the supernovas are in are away from us. And so the big discovery is that Professor Reiss and his team basically analyzed a bunch of type 1a supernovas, and they found out that the brightness was in fact fainter than expected, which would mean that they were much farther away than expected too. And the only way to explain this would be the fact that the universe's expansion was accelerating and not decelerating as was previously supposed. And because gravity is supposed to attract things together, physicists thought that expansion should be impossible. So they had to come up with basically a different theory to sort of explain why the universe was accelerating, or the universe's expansion was accelerating. And so they basically revisited Einstein's idea of a cosmological constant and gave it a different name and called it dark energy. So why Professor Weiss's presentation interested me in particular is because it really helps satisfy my curiosity about what is beyond Earth, since in the grand scheme of things, us humans are just tiny specks in the larger history of the universe. And so it's really cool learning about the history of the universe in the same way, it's cool learning about your family history. You sort of get to know a little bit more about yourself, I guess. Adam Weiss's discovery, to be honest, might not have large-scale immediate implications, like maybe, the discovery of fusion would, but it's a great example of the ingenuity of humans. Like, it's amazing how with just 1990s tech, where, computers were still pretty rudimentary, they were already able to calculate the distance of galaxies. That's really impressive to me. And I guess, in general, just learning from smart people is really cool and interesting. Some key learnings and takeaways that I had from Professor Weiss's presentation is all the history behind how we discovered that the universe is expanding at an accelerating rate. Because prior to his presentation, I had already heard of the concept of dark energy, through documentaries, YouTube videos, and even the Big Bang Theory, but I had no idea about Einstein's cosmological constant and all the debate that went into all the debate and research that went into this theory. I guess the most interesting fact would be the fact that Professor Reiss and his colleagues were competing with a separate team to be the first one to finish analyzing the Type 1a supernovas. And also, it was interesting how when Professor Reiss found out that the expansion was accelerating, many of his colleagues who were on the same team as him didn't even believe it. I guess it was like that shocking of a discovery. Now, to go a little bit beyond Professor Weiss's lecture, um, so Professor Weiss made this discovery in the early 2000s, I believe, or published his findings in the early 2000s. And so, it's been basically 2 decades since that, and we've had new discoveries and new theories to explain sort of the expansion of the universe. So first of all, better and larger supernova measurements have helped refine how accurate our predicted expansion rate is. And then there's also the theory that dark energy might not be constant, because the assumption is usually that it has uniform density and pressure, basically how much expansion it can exert, sort of. But recent measurements have sort of been thought to disprove that, although the accuracy of these measurements is not fully conclusive yet. And then there's also an important fact, which is the Hubble tension, and that's basically physicists found a new way to measure the expansion of the universe using the cosmic background radiation that was left over from the Big Bang, and those results didn't exactly match up with the calculated expansion rate that Professor Reiss and his colleagues made using Type 1a supernovas. The new theory sort of tells us that the expansion should be slower than what Professor Reiss found it to be. That's it for this presentation. Thanks for watching.